Morning students. In the last class we have done area of triangles and today we are going to deal with area of quadrilaterals. Now you all know what a quadrilateral is. Quadrilaterals are four-sided figure. You can see this figure ABCD is a quadrilateral having four sides. Yeah, we have learned about different types of quadrilaterals that we will study in detail afterwards. Okay. Now how to find the area of this quadrilateral? Yes, if I divide this, if I join AC, I can see that this quadrilateral is divided into two triangles. That is ABC and triangle ADC. And we've already learned that area of triangle is half into base into height. So we can say that area of triangle ABC will be equal to half into AC into perpendicular. If I drop a perpendicular BM to AC is the height. Yes, so into BM. Clear? Half into AC, base into height. Similarly, if I talk about triangle ADC, area of triangle ADC will be equal to half into AC base into height is DN. Clear? So we have divided. How are we finding the area of quadrilateral? By dividing it into triangles. Just draw one diagonal, if we know one diagonal, and drop perpendiculars from the other two vertices on this diagonal. If I know DN, if I know BM, and if I know one diagonal, I can easily find the area of this whole quadrilateral. So we can say area of quadrilateral ABCD is equal to area of triangle ABC plus area of triangle ADC. And what is area of triangle ABC is half into AC into BM, and area of triangle ADC is half into AC into DN. Now if I take half into AC common, we are left with BM plus DN. Now we can say, we can generalize this as a formula. If I know a quadrilateral whose one diagonal is known and the perpendiculars from the other two vertices are known, then we can generalize that area of quadrilateral is half into the product of one diagonal into sum of lengths of the perpendiculars drawn from the other two vertices. We will not take these vertices AC, yeah, because this is already, they have already been considered in the diagonal, first diagonal, yeah, and the product of the, it is half into AC, one of the diagonals, into the perpendiculars, sum of perpendiculars BM plus DN. Clear? How did you get this? I hope this is clear. Now coming to, if these two diagonals are perpendicular to each other, if in a figure that there is a quadrilateral ABCD and the diagonals are intersecting at right angle. If the diagonals, when diagonals intersect at right angles, then what can you say about area of triangle ABC will be half into AC into OB, and area of triangle ADC will be half into AC into OD. Clear? Half into AC into OD. So if we add these two, what do we get? OD plus OB. OD plus OB will be equal to what? Is equal to BD. So we can say half into AC into BD, the product of the two diagonals. When the diagonals, this is only the case when the diagonals intersect at 90 degree. Then we can write the formula as half area of this whole quadrilateral is equal to half into product of diagonals. But when the diagonals do not intersect at 90 degree, then area is half into diagonal into the sum of perpendiculars drawn from the other two vertices on this diagonal AC. Clear? Now coming to special quadrilaterals. You have been studying about rectangle, a square, yes, all these quadrilaterals, four-sided figures in your previous classes also. Yes, from childhood you are learning this rectangle. Now coming to rectangle, let us learn the properties of rectangle first. What is a rectangle? Whose opposite sides are equal. Yes, this is equal to this, and this AB is equal to DC and BC is equal to AD. Clear? And what else have we studied? That each interior angle is of a quadrilateral, of a rectangle is 90 degree. Each interior angle is 90 degree here. Yes? Okay. This is called AB is the length, BC is the breadth, and AC is called the diagonal. Already studied that, see, if it is divided into two parts, if you can say a rectangle half into L into B and half into L into B. So these two triangles add up, that gives you the area as length into breadth. There's no need, yes, you already know that area of rectangle is length into breadth, but how it is coming is, if we divide it into two triangles, the area of this triangle, right angle triangle, is half into L into B. Area of this triangle will also be half into L into B. Half plus half make 1, that is L into B. Perimeter, already know sum of all sides is the perimeter. So 2L plus 2B is the perimeter, or 2 times L. Now can you find the length of diagonal? Diagonal is, yes, apply Pythagoras theorem in this triangle. If you know length as L and the breadth of the rectangle, so diagonal is under root L square plus B square. This is coming through Pythagoras theorem. So I think rectangle, you all know the properties. Coming to square. Square again, all the 4 sides are equal. Each interior angle is 90 degree. Yes, and all the 4, each interior angle is, now this is the diagonal. So what can you say about the area of the square? Area is side square. Again, you have been learning this since childhood. Yes, A half, again if you just see this, the area of this triangle ABC is half into A, that is half A square, and area of this triangle ADC is also half A square. So half plus half gives you 1A square, or side square. When we come to the perimeter, is the sum of all sides, that is all sides are equal to A, so 4 into side, yes, or 4A. Coming to the diagonal, again apply Pythagoras theorem and you get the diagonal as A square plus A square is AC square. So AC is equal to under root 2A square, and A square, if you take this out of the root sign, you get A root 2 is the length of diagonal of a square. If you know the side of a square is anything 3 centimeter, then 3 root 2 will be the length of its diagonal. It should come automatically now. Next is a parallelogram. I hope you have studied parallelogram in class 8 also. What is a property? What are the properties of parallelogram? Its opposite sides are parallel as well as equal. That means AB is parallel to DC and AD is parallel to BC. AB is equal to DC and BC is equal to AD. But it is not a square. Opposite sides are parallel and equal in a square, rectangle also, in a rectangle also. What is the difference between a parallelogram and a rectangle is that, yes, in rectangle all interior angles are 90 degree, but in parallelogram all interior angles are not equal to 90 degree. Clear?